So we will be getting started in a few minutes. So we're waiting for everybody to come. We're about 8 minutes ahead of time. So, but we got everything situated and ready to go. So we will.
Yeah, that's good. All good.
What I'll do is I will monitor the question window.
Yep, let me know.
And then I'll be on mute, but if there's a question comes up, I'll break in probably and get you to answer that question. If it's something I think can be done afterwards, I'll just leave it till then. But we'll go with that approach, I think, for the moment.
Yep, sounds good.
Okay, just to let everybody know, we've still got about 4 minutes before we're going to get started, so we other people have a chance to get on to the call.
Yep, sounds good.
Okay, we'll give everybody just about another minute, and then we'll get started.
All right.
Again, for everybody, if you've got questions during the talk, please put them into the question and answer window. I will be monitoring that during the talk, and then I will get those questions answered. So, and again, to remind everybody, if they want to, they can't get a hold of get a hold of me with the Zoom. I am monitoring the hashtag GIB 2020 MEL. That's where the links for the next talk will be popping up there too. So without any further ado, I will hand over to the speaker. Thank you very much.
All right. Good morning, everyone. Hopefully you can all hear me well and see my presentation while you have, comfort in your own home desks. Getting the most out of the situation, at least looking at the bright side. No need to commute today. My name is Ahmed, and I work as an API platform manager at AGL Energy. My team is focused on the Azure integration suite, mainly API management and Azure Service Bus at the moment, plus looking after interaction or integration with app services, function apps, and all the nice stuff that we have heard in the previous session. And today, basically, I want to talk about the API management product in Azure. And specifically, I'm going to talk about DevOps and the journey that AGL Energy took in terms of streamlining the DevOps practices and the pipelines as far as API management is concerned, and take you through a little bit of lessons that we have learned along the way. But I will start by a quick introduction about API management and why an organization might need API management. And I'm sure you're all familiar with this monolith architecture that we used to have many years ago. And then we have taken that and developed it into a model where instead of having those components tied into a single application or unit of deployment, we spread this out to multiple microservices that you can separately deploy and separately maintain. But with that, many challenges also came. Part of it is how to manage cross-service concerns like security or performance or caching or throttling or anything that you basically wanted to be standardized across your organization or across your application. And then some few patterns came in to solve that problem. One of the most important patterns is API gateway, which is basically a single gateway that's highlighted here to all your microservices in a specific application. With that single gateway, you can control access to your services and provide other values or added values like management and service discovery. For example, provide your organization with a directory of all your services where you have a nice way to get documentation and discover the capabilities of APIs within your organization. And I will talk in detail about that. But I just, as an analogy, I want to mention a little bit about maybe 15 years ago, there was a hype of, aspect-oriented programming, and it's pretty much similar to microservices, but we are talking about software modules or functions here. And aspect-oriented programming was promising to move all those shared concerns into centralized modules, where you can just have a pipeline similar to that one, and then like a product similar to PostSharp would go and apply those aspects into your code, leaving your functions free of those concerns that seems redundant and seems unnecessary to have to list it everywhere. Similar to that, API management provide the capability of having a pipeline where request starts from the client all the way to the service at the back end, but we can interfere anywhere between and add behaviors based on the situations. So it's not about the exact set of behaviors that an organization would have at any point of time. It's mainly about the capability of adapting to change and adding behaviors to the pipeline per needed. And that's where the strength came of using a system like API management. To give you a few examples, security wise, it's a dynamic landscape where lots of threats happens every day. Few examples, like the moment any news about AGL, like an acquisition or similar, it's like all those DDoS attacks starts to happen. And then different kinds of attacks. And then you need to have a smart system where based on the changing behavior of those attacks, you need to inject behaviors that prevent those kind of attacks. So you're gonna have to have a way to have a smart pipeline where you can inject behaviors that applies to all APIs within your landscape at any point of time. So firewall is one example of those behaviors that we can just attach to the pipeline, and APIs at the backend wouldn't have to worry about that. Obviously, for compliance and security reasons, it's better to address these concerns at the gateway instead of addressing it at each individual service. Bot detection is interesting one. Previously, organization had attacks like, for example, hackers have a big list of credit cards and they're trying to hit a particular API just to test if the credit card is active or not, or valid or not. And then that kind of behavior is you want to determine between human or bot, right? And what you want to do is you want to be able to inject into into your pipeline behaviors like bot detection at the time you understand that you're under attack. So it's about what you know already, and it's about also reacting to situations. Also stuff like monitoring, throttling, authentication. Authentication is interesting one. In your organization, you might have legacy systems that, for example, using basic auth. Clients have to pass username and password to access your API or your system. By having an abstraction, API management abstraction, what you can do is you can provide a more modern authentication mechanism and hide the the complexity or the weaker security implementation of your older system behind a more modern system. And we are doing this a lot in AGL. So it's just not just addressing new systems, also addressing existing systems and be able to provide a layer on top of it, extra layer of protection, and a nice interface on top of those systems. And also, like talking about more of reasons why you need API management is, we talked about most of these, but connecting internet clients with corporate system is also an important one. And Bill mentioned about on-prem gateway and stuff like that API management can provide. But also, like, one of the important features is VNet integration. So your corporate APIs might exist in a virtual network in Azure, and with having a VNet integration between APIM and your backend corporate systems, you can connect to those systems, whether they are on-prem or they are in the cloud in a protected network. You can provide internet proxy into it. We also use some of these techniques a lot at AGL. API as a product is interesting. All the third-party applications or third-party integrations that want to use your API as a product, and API management would provide a nice way to manage subscriptions to those products, legal requirements like accepting terms and conditions, and having quota, and rate limiting, and those enforcements can be applied at the subscription level. So it allows you to manage that pretty good. Also, you can have centralized telemetry regarding all your API traffic. So we understand, okay, the benefits of API management for AGL, but let's talk about challenges for achieving a streamlined DevOps strategy. The size is the biggest challenge. Big enterprises are big. It's a big enterprise. This is our GitHub repo for AGL, and you could see only in 1 week, there's like 455 pull requests going into all those source code repository. It's a huge amount of code. If you have a look at the number of repositories, it's also big number, and you can, from knowing that, it's like even not all of our code is in GitHub. Like, we are talking about massive number of applications, massive number of APIs, massive numbers of teams that has different skill sets and different focus areas and different circumstances, and they work with different technologies. We also have systems at the back end like SAP or systems using PaaS services, and systems using serverless, and systems on the corporate network, or systems on the internet, and different ways to authenticate to API. Like, we have OAuth2, we have Basic, we use O0, we use Azure AD, and so on. So this kind of bigger landscape and this size introduce a challenge. How do we develop a way that would allow all these teams with different mindsets to work toward achieving like unified goals for that API program, and how they work together, and stop duplicating and wasting duplicating code and policies, and comply to standard policies. And that's what I'm going to talk about. So in order to progress in our strategy, or in our DevOps strategy, we had to define some values. And when I first joined AGL, and I was actually lucky to see these as our AGL values. These are just one pillar of our values, but it's the pillar that I was focusing on while trying to introduce some of those changes to streamline the DevOps processes. They're basically talking about breaking down silos. When you have this number of teams and you have operation teams and you have feature development teams, you need to always be aware of this silos problem. People tend to rely on different teams if they are relying on them to do work for them, and they would feel, okay, they are blocked by a specific team need to finish something before they continue to work. And being a centralized team that's kind of serving all this big number of teams, it's really essential to change this relationship to be a collaborative partnership, to work together instead of doing work for different teams, and to unblock each other instead of waiting for each other to apply changes or drive changes. So we had these in our values, and we developed a few principles that would allow us to achieve those goals, or in the line of those values. Some of those principles would basically using as much infrastructure as code. We are talking about development communities where the biggest artifact that they interact with day to day is code. So as infrastructure teams or operational teams, we want to provide this coding interface for development teams to start consuming. So it's like for us, we want everything to be as code, infrastructure as code, configuration for those infrastructure need to be in code, and pipelines also need to be all expressed in code. And by having everything in code, we can have smart pipelines that can validate our changes, and people can review those changes, and it goes into a CI/CD pipeline that making sure that safe changes is applied to production environments. By that, we introduced the concept of self-service via code. So as long as all these changes travel as code, then we don't have to use emails anymore. We don't have to use service requests anymore. We don't have to assign requests to people. All what we need to do is to have a smart system where different teams can contribute via code, and then automation can run on top of this code, make sure that everything is okay. Even human interaction is now centralized around code. So think about pull request, comments. It's kind of people really familiar with that. It's really robust way of collaboration is to collaborate around code, is to go and point to a specific line of code and say, okay, this is few comments around that. This is how we are deviated from our API strategy, and this is where we are aligned. And that makes lots of difference instead of wasting time in manual processes and email and so on. So a little bit technical in terms of how we achieved that. In infrastructure as code, we have chosen to use ARM templates as a way to express our infrastructures, our infrastructure components. And one of the most powerful features in ARM templates is link templates. What link templates allow you to do is, instead of having a big monolith template, it allows you to split and modularize your templates into sub-templates and sub-templates, levels of templates, and so on. So we achieve the same, we achieve modularization through link templates. So we would have a big master template. Sorry, it's not a big, so it's like a starting master template that only links to a couple of other templates. One of them is API Management template, for example. From API Management template, it also achieved the same modularization by having a children template related to products, APIM products, APIs, and subscriptions. That's just a simplified example. And APIs, it also does the same modularization by going even to the API level template. So these are APIM APIs in the hierarchy, where you can deploy those APIs separately because you can have them as separate templates. So at any point of time, we can either deploy that level of infrastructure, we can deploy to that level of infrastructure, we can deploy to that level of infrastructure. We can also separately deploy those API pipelines that only affect specific APIs and does not have any effect on the entire system. So basically, the collaboration model can be described as API management is this entire big box. Those constructs at the bottom are like policies and configuration and resources that can apply at the service level. And these are maintained by the platform team, my team. When I say maintain means we own this part of the configuration, but other teams can also contribute to this part of the configuration, right? But so the sense of ownership here has to be respected. API teams would also own their part of the configuration. So they have their API definitions in Open API, they have their policies, they have the configuration scope to their APIs. They own this part of configuration, and other teams also own their specific part of configurations. And with that model, API teams can contribute to shared components, and platform team act as a validation, building validation and pipelines that make sure that those shared configuration and also API specific configuration behaving in the way that that we want from the entire system. And then that collaboration becomes more like a code review kind of style. So it's like conversation that can be inside code review comments or, you know, like meetings or catch-ups or whatever, but it's centralized around code that we can all see, and an audit trail that's visible for everyone. And also the sense of responsibilities and ownership, and everyone knows how to do safe changes. So for infrastructure as a code, the project structure would look like this. So we have a master template at the root level, and we have those levels of templates similar to what I mentioned. And API platform team would be responsible of that level in the infrastructure. And we have single API scope. And by the way, I have uploaded this example setup in GitHub, and I will share the link at the end of the presentation, so you can have access to all the code and all the pipelines and stuff like that. Single API scope is where API teams have access to this level of the infrastructure, where they can do change scope to their own APIs. And API template is like the constructs of that level is API template and policy file, which is the APIM policies related to that API, and then also a pipeline like what I will mention soon. But that's the scope where API team can safely make changes. You will also see parameter file per environment, which mean configuration as code as well. So any configuration that they might use in their template, they can pass in those parameters. In order to achieve that level of diversity and all those all this control that we want to give to team, we had to use pipelines as code as well. So for example, we opt in to use a multi-stage YAML pipeline in Azure DevOps, which would allow for every, similar to this presentation, this build.yaml that actually sits inside the API template, which is driving a a YAML pipeline that takes the code, takes this part of a project all the way from build to development environment to pre-production and all the way to production. So basically, this pipeline now is owned by the development teams, and once they change it, we get to validate using automation, and we get to review the code that they implement in their pipelines as well. And one of the good things about YAML pipelines is the concept of templates. And I will show you soon that those artifacts are laid out in a way that shared templates is developed by the platform team, which means they can opt in to use a specific template like that has encapsulated most of the logic that is related to deployment, but they can also hook up to this pipeline and add their own custom templates and or trigger different behaviors and so on. So it's a combination between having flexibility of your deployment pipeline and figuring out your environments and stuff like that, and also reusing some of the investments and sharing investment where all the API teams can just utilize because it exists at the platform level. So going into project structure for pipelines as code, there's a master pipeline, and you can actually see from its definition that it's excluding any changes. It's not triggered by any changes in this path, which actually related to individual APIs. And so it would apply for, it would be triggered for all the service level changes in the configuration. And there are API pipelines that sits under the API, and it would only get triggered if changes happen into this part of the configuration, either through the pull request or the CI trigger. And these are the shared deployment templates that I was talking about, that is abstracting the complexity of deployment and having a standard way of deployment. And this is where our guardrails can exist in terms of pipeline security and stuff like that, but still allowing teams in their own pipeline YAML files to override some of the behavior or add existing behaviors and so on. Pipeline security is important, like with all these teams having access to like a centralized repo and different pipelines that exist in the same repo, how to make sure that those pipelines are secured. But by that I mean only the team that owns this individual asset have access to trigger those pipelines. We achieve that by managing security at the directory level in Azure DevOps. It's a pretty nice feature that would allow us to set up groups or teams in Azure DevOps to have access to specific directories, and then we can add all relevant APIs in the same directory and assign permissions and manage security once. And that's something that assigning those kind of permissions and policies, it's something that the platform team would be doing. In order for this to work, we have to have a very smart validation framework. So making sure that all these changes are safe. For example, team A does not change in API that belongs to team B, and so on. So we have validation pipeline, including like X unit tests and stuff like that, that make sure that it does static analysis of the ARM templates and suggest fixes for common problems, or any kind of problem or any kind of problems that is kind of preventing teams from doing safe changes. And the experience is basically need to be very, pleasant and very easy for development teams to contribute to. That's why we pay attention for things like the messaging that we send to teams. And we have the concept of even user experience when we talk about our development community, and how to be how to suggest exactly what's going wrong in simple words, so they can understand where they need to fix. So we chose a way where we can declare API configurations very simply. So if you have a look at this path here, that's the actual API path, and that's the template for API where API teams would be using. So if you see its structure, it's pretty simple. It's just in variables, they need to mention the display name of the service, description, and how they want the service to be called, existing versions where they want to be interested in, API products in simple words and not so complex, but then pushing complexity down also in standard or generic behavior, where we have most of the implementation, infrastructure implementation exists in those shared templates, so they can just use it as a function, but they also have the flexibility to run a deployment after that deployment to represent a specific need that they have, or before that deployment that represent a specific requisite that they have. It's a combination between having a simple interface and also having flexibility to do stuff that's not very generic, do specific things. So we are relying on a feature in ARM template for API management. It's related to importing Swagger definitions. So basically the concept is API teams in the backend services would have a way to host API definitions for their APIs. And all what they need to do as part of the API configurations here is an API definition URL where we go and import the Swagger definition into a specific API. And then in that standard implementation in that resource, in the API resource, we would import this API definition with the API definition format that can be, Swagger or OpenAPI or WSDL or whatever. It's all flexible and all can be defined as parameters into API management. So pretty simple interface, pretty simple interface here, and the implementation is added generically for all the teams. API policies is one of the important part of API management. This is where you have this pipeline that I was talking about. Starts by an inbound request and an outbound request and the backend call itself, and then error handling. And API teams can, inside the API directories, can express their policy files in code, including any custom policies or policies that they want to be adding. And inside the template file, they just need to point. So also going back to the simple setup of parameters, they can also provide their policy URL. So in this example, that they are passing policy XML to the next template. And then here we are just provisioning this policy based on that policy URL that has been passed. API configurations is interesting concept. So API management supports configurations similar to app settings or web.config values. They called it named values. The biggest limitation for named values is they are not scoped to a particular API. Instead, they just have a service scope. So what we want is this is where we interfere and build something for to be, like a generic implementation to be used by the teams to solve this kind of problems. So instead of stepping on each other's toes and having different values, because they sit in the service scope, then there is always the possibility of stepping into each other's toes and using the same name, which would override the value that has been actually pushed by a different name. So what we are doing here is we providing in the parameter file for the specific service that's being maintained by the API team, we provide simple array of name values for name values. But what we do is we namespace those names, appending API ID to it as part of our templates. So we end up with a nice way to, even though this name value was being added as current environment, we append API ID to it. So it's namespaced, and we always guarantee there are safe changes and not overriding each other's templates. Name values or configurations. And by pushing name values into this level of the pipeline, we can also ensure that we want the teams to own their own pipelines that would update that specific API configurations, and they don't have to go and update the service configuration, which has a bigger scope in order for them to do any changes. So what we end up is by having all those investments, what we end up is collaboration between teams. And the reason why we have this level of collaboration is because we have used the language where development teams are using in their common day-to-day activities. We used code, and then we provide a streamlined way for them to apply these changes. We also provide the guardrails where teams can safely apply changes in isolation from artifacts that are changing other parts of the system. So we end up with more collaboration. We end up with collaboration around code. This is kind of 1 month activity in our code repo, where the good thing about that is most of people in this list are people outside of our team, contributing with their PRs to the program. And this is where we drive API strategy. This is where we drive a standardized API approach within the organization by having this, right proper situation where we can comment and collaborate around code. It also streamlined the process of having a standard API guidelines and standardizing all our API behaviors. I have a slot for questions and answers. Like if you have sent any questions to Bill.
So far there isn't any questions.
Right. Let's just give a minute for people to send questions. Basically, we have 7 minutes left.
I have one question.
Yep.
How do you handle functions?
When you say functions, you mean at the back end there are Azure functions?
So do you force the functions to have the Swagger?
Yes.
Okay.
Yes, yep. Correct. So functions, app service, any piece of infrastructure, they need to be able to provide an API definition for the API. And there are 2 ways that API definition can live. One way is similar to that policy file that we have in the source code of the repo, like it's already inside next to the other configuration. similar to having policy.xml, we sometimes also have swagger.json, which means it's kind of an API first development or definition first development, where you can update the definition and then work on the implementation and so on. But that's not as common as using a tool like Swatchbuckle or other tools, or NSwag that can update, generate API definitions from code, and that would deploy to that. And that would deploy to that URL, which is added to those templates. But whether it's an Azure function or an app service, yes, we expect API definition.
Okay. One question: any external participants using the APIs to do with sustainable energy solar feeds?
We do have lots of external organization consuming our APIs. In particular, that use case, I don't have something in my mind, so that might be the case or might not. Basically, because third-party subscriptions and stuff like that is kind of managed by the teams who owns those particular APIs. And we are just facilitating that. So I know, for example, organizations like, iSelect or different kinds of organizations that is to do with, sales pipeline. We have a lot of these, but I'm not aware of that integration.
Okay, another question. You described your IAC being based on ARM templates. How does AGL use Terraform? Use of Terraform fit in? Is it not used for deploying APIs?
At AGL, we use both Terraform and ARM templates, and this is the deployment that's related to API management and API configuration, right? Teams might have different way to deploy their backend services. You always have to respect, like knowledge and heritage for each individual team. In this case, we can use different technologies that serve the same purpose eventually. So it's not a single deployment that has API management and also backend services. This deployment model is only for API management configuration. The deployment model for backend services can be different to that, and the pipelines is already different to that. And templating, infrastructure as code templating can also be different to that. I know we use in many areas we use Terraform, but we also use ARM templates in different areas, including API management. For us, it's not really important the difference between ARM and Terraform. They both, tools that would achieve the purpose if you use them well. We just picked ARM template. We could have just picked Terraform and did exactly the same setup.
Yeah, and I think you may have run into early on with some of the Terraform. There wasn't as much support around API management in Terraform.
Exactly. Yes.
So,
well, always it's always I don't want to get into the debate between Terraform versus ARM. It's pretty popular, but yeah, you use a tool and then you take its pros and cons. But one of the cons in Terraform is it's always lagging behind the vendor, because they have to add a specific implementation for each API once it's released. So you would always have this features available in ARM first and then Terraform. It's one of the pros if you picked ARM. There are other pros if you pick Terraform, and that's it. That's like any other technology choice that you would do.
One of the good things I did hear from Microsoft through the MVP is that they've actually dedicated a person in Microsoft to liaison with Terraform.
Yep.
So that they know about all the changes and they're up to date with all of that stuff too.
Yep.
Another question. Any tools to link website UI to API call documentation? for example, so developers know what it means to happen when you hit the submit button is clicked, things like that.
Tools that link.
It's kind of, but make it easier for them to look at the documentation from APIs.
Yeah, so the developer portal is a great tool to look at the documentation for the APIs, and the new developer portal in particular is kind of pretty good. It's fast, and yeah, you can get a Swagger similar to Swagger editor, Swagger UI. You can get a like a playground where you can test your APIs. I think there are also tools of pushing notifications about changes and changes in the API in terms of features, new features and stuff like that. We haven't actually used that, but we use like other ways of communication, pushing up changes. But if your question about getting the developer experience, it's the developer portal UI.
Yeah, so I think one of it was also is that when a developer goes into like a website and it's in behind this button click, they see a call to an API. Or is there any tools that you were using to kind of make sure it knows how to find the documentation for the API? Or is it just depending on them to basically know to go to the developer portal and look at those APIs?
Yeah, I'm not aware of a tool like that. I would say they have to know the documentation before they write the code that add this to the application in the first place. So
another question is, or in prototyping communications, not exactly sure which one that follows on from. It's just or in prototyping communications. The developer portal is very handy for doing those type of things. And then UX design communications to programmers. Basically, again, the developer portal is really focused, I think, around the API itself. So it depends on what tools you're using to document your UI design and UX design. So, okay, any other questions? Okay. I think that will finish us up. You want to have anything else to say?
Thanks for participating and thanks for coming up. And this is my Twitter handle if you want to get in touch. And I already published lots of those examples and artifacts to this GitHub repo. So if you want to have a little bit of guidance on a smaller scale, you can have a look at that. And that's it. Enjoy the rest of the day. And thanks, Bill, for organizing.
Thank you. And basically what I'll do is I'm going to end this particular meeting, and then we'll start up the new one shortly. And thank you very much.